4.2 is talking all about polynomial division. We have two types of division. Pretty much polynomial division is testing to see whether or not something is a factor. For instance, like if we took 24 and divided it by 6, we're basically testing it to see if it's a factor. Now, because 6 can go into 24 4 times evenly without a remainder, that means that 6 is a factor of 24. So we're looking at the same thing. We're going to use some long division. We're going to use synthetic division to go ahead and find out if things are factors, and if they're not, what are their remainders, and what does that mean about them in terms of our polynomial. So the first thing I want to do is just review long division from way back, probably in elementary school days, and how we do the process. So remember, in long division, what we're trying to do is figure out how many times 7 can go into each one of our pieces. So 7 would go into 5 0 times. Now, you don't have to put the 0, I just use the placeholder, right? But 7 can go into 59 8 times, and 8 times 7 is 56. We subtract that to get what's left over, and we bring down the next place. 7 can go into 32 4 times. 4 times 7 is 28. So we need to subtract that, and we're left with a 4. Drop down our 3. 7 goes into 43 6 times, and that would be 7 times 6 is 42. And when we subtract, we're left with a 1. And the last, 7 goes into 18 2 times. When we multiply that, we end up with 14, and we have a remainder of 4. Right? So normally, right, when we were doing long division, we write something like this. We have a remainder of 4. With polynomials, we're going to take the same idea, and we are going to use the same idea to figure out what's going to happen. So if we take a look, we're looking for this first term right here to match up with the first term inside. So in order to make x become an x squared, we can multiply x by x. We're looking for this on the outside to become the same as the inside. So x times x would give us an x squared, and x times -3 would give us a -3x. We're still going to subtract in this case, so x squared minus x cancels out, and 3x minus a -3x turns into a positive 3, and that would give us a 6x, and we could still bring down our -12. So now we want this x number in front to become a 6x. In order to do that, we can multiply by 6. So 6 times x is 6x, and 6 times 3, -3 is -18, and we can subtract. Again, the whole goal is you want that first term to cancel out so that we're actually eliminating something as we go down. -12 plus 18 will give us a 6. So our final answer, though, is going to look like this. We have, when we divide, we're dividing x squared plus 3x minus 12 divided by x minus 3. Okay. Our solution is x plus 6 plus. Now our remainder is 6, and it's going to be 6 out of x minus 3. I'll do one more problem for you here. So the next part wants to determine whether or not x squared minus 1 is a factor for each polynomial. Okay. Here we go. We'll line it all up. Another important thing to remember is that you have to have placeholders for anything that's not there. Okay, fortunately, we have to the 4th, 3rd, 2nd, 1st, and then our constant. So we have all of the place values taken care of, but that is one thing you do want to check for. So we're first looking for our x squared to become a 4x to the 4th. So to get a squared to become a 4th, right, if we multiply it by another x squared, that will become that. And to get the coefficient of 4, we can throw that in the front. Again, I'm going to line it up over my x squared just so everything is in line and I can figure out where the end of my problem will be. So now I'll distribute again. 4x squared times x squared gives us 4x to the 4th. And 4x squared times a -1 is going to give us -4x squared. Okay. Notice that I left a space in between because I want to combine my like terms. Okay. I don't have anything that became an x cubed, so I'm going to leave that space open. My 4x to the 4th will cancel, Now when I drop this down, x cubed minus nothing is still going to be x cubed. And negative 10 plus 4 is going to give us a negative 6x squared. And now we can just drop down our next piece, which is a minus x. Now I'm looking for my x squared to become an x cubed. In order to get that, I need to multiply it by an x. X times x squared is x cubed, and x times negative 1 is a negative x. Here we're going to subtract again, and notice I left my space for the x squared. My x cubes will cancel out. I'll still be left with a negative 6x squared, and negative x plus x will also cancel out. The last piece to drop down would be my positive 6. To get x squared to become a negative 6x squared, we can multiply by negative 6. Negative 6x squared, and negative 6 times a negative 1 will be a positive 6. And if we subtract all those things, we end up with 0 as our remainder. So our answer to this problem is yes, it is a factor. Right? We come up with a remainder of 0. That means that x squared minus 1 goes into, or is a factor of, 4x to the 4th plus x cubed minus 10x squared minus x plus